Department of Higher Education. It's my pleasure to welcome you to today's webinar. I'm Shel Junker at Terra Community College and co-lead of the Communication, Outreach, and Engagement Subcommittee of the Ohio Mathematics Initiative. Joining me today are John Gregory from Columbus State Community College, Sari Hedges from the University of Cincinnati, Don Davis from Lakeland Community College, and Martin Molenkamp from Ohio University. And they're here to help us all with getting up to speed with TMM 026, the Introduction to Data Science. Before we begin the actual presentation, please take a moment and make sure that you've muted yourself and turned off your video for the best viewing experience for all of the participants. The presentation will be recorded and available to you and any interested colleagues in the near future at the Ohio Mathematics Initiative website. We'll populate that in the chat here before the presentation ends. We are monitoring the chat during the presentation, and there will be time for open discussion between our presenters and at the end of the webinar today. With that, I would like to introduce Ricardo Muerna, University of Cincinnati, and panel lead for Ohio Transfer 36, Mathematics, Statistics, and Logic Group, who'll begin today's discussion. Go ahead, Ricardo.
Yeah, well, good morning. Good afternoon now. Just a little bit of background on the data science course. During pre-pandemic times, Professor Stephen McCurchin from the Ohio State University, expressed that there was a need to design a general education course that will contain the basics of data science and that could be offered to the liberal arts. A group of, I believe it was 7 faculty members from the state, from representing all of the spectrum 2, 4, and R1 universities, met and presented a set of learning outcomes. These were sent to the 36 public institutions, I believe it was in December of 2021, for endorsement, which is the usual procedure. Finally, after some small changes, we have those learning outcomes endorsed. And right now, there are many institutions that already have designed a data science course or are in the process of designing one. So we thought that it would be a good idea to have this webinar to show what other people are doing in that direction, and also to create network. If there is a need for assistance doing something, now we have a larger group that can work with it. The entire idea is, first of all, data science is one of the most needed professions in nowadays world. And on top of that, with this course, we are attempting to create an interest in students to pursue careers in data analytics, which is going to be, actually, we're going to have a shortage of data scientists in the Midwest pretty soon if we don't do something about it. So with that, I'm going to just let the webinar go now.
Thanks, Ricardo. Our first presenter for today is John Gregory from Columbus State Community College. And John, I think you should have presenter abilities now.
All right, thanks. Give me just a second. I'm going to turn everything on. Okay, let me get that here. Okay, so I was on the team that developed the learning outcomes, and I kind of came in as a novice of data science. So I just want to acknowledge all the help that I got from Sari and Don on this in particular. And what I wanted to talk about is just our target audience. So my experience is mainly with statistics and quantitative reasoning, not necessarily on the STEM track. So I think there's a little bit of overlap between those students. So our target audience for this course is similar to, I would say, quantitative reasoning or statistics. It's designed to be a terminal course. So that means for most students, we have basically 1 semester to make an impact. And so my presentation is sort of from the perspective of the student coming in off the street we've got them for 15, 16 weeks, and then they're on their way. If we have a class of say 30 and we get maybe 3 people interested in data science and they decide to pursue maybe a CS or a statistics degree further, that's great. But for the majority of them, they're here for 1 semester and then they're moving on. So what I wanted to do was pick out 4 learning outcomes where we can be more impactful. And some of this is based on conversations that I had with the developers, with my colleagues. We had a discussion about this at the Ohio Matic conference a couple years ago, and some of the feedback that we got when we sent out the learning outcomes initially. And so they're mainly around graphing and misleading graphs, and then bias. So that's going to be in, I think, outcome number 2 is visualizations, and outcome number 5 is ethics. So I just pulled out some of the information, and then I found a few examples of things that we might be able to present in a class and get the conversation going around visualizations, particularly bad ones, and then conversations around bias. Okay, so the first one is, it's 2.5 and it's the time series plots. This was the area where that I worked with. I worked with the team in particular to develop these particular outcomes. And the idea with this is we want to have our students avoid extrapolation and jumping to conclusions. So this is something that you're going to see in a statistics class too. So we always talk about that when we do statistics or if we have some modeling in quantitative reasoning. And the problem is sometimes people are a little too trusting, and they're in technology. They're like, well, this is cool. This app is great. Or they're not thinking critically, and it's a failure to consider error in the models and predictions. So one of our conversation starters or sample activities was building a model to predict the weather. And if we could find data from say 1900 to present or over 100 years, we could fit a trend line and then try to predict say rainfall, temperature, dew point for a particular month, May 1997. We can build a model and then go back to the data and verify our prediction. And there's going to be some error. So again, this is the student that we have for 15 weeks. So we want to talk about, why is there error in these models? Why don't we get the perfect score every time? Another thing we could do is if we can predict the weather, we could make observations and see if our prediction is correct. And again, come back to the idea of error. Of course, our prediction for a 1 or 2 day forecast is going to be a lot better than a month. The next thing I want to talk about, let's see if I can scroll over, is misleading graphs. And so media literacy, that's kind of a big deal, and that pops up in our other courses as well. And the idea is we get bombarded with information, we get bombarded with visual information, there's misleading graphs everywhere, and they can be quite convincing. So one of the possible ideas for exposing our students to that is to have them go and find those graphs in the wild. So go find some bad graphs, bring them back to class, and let's talk about it. They could be like the classic non-zero axis, or pie charts versus bar charts versus histograms, or the awful pictograms that are on the cover of USA Today every single day, right? So if we can come back into class, talk about what's going wrong, we can get them thinking about, okay, well, maybe this isn't the best way to present the information. A way to extend this could be, well, what if we have the actual data, or what if we can rerun the survey and then choose the appropriate method for displaying the information? And I have a couple examples for that. So here's one, and it's a survey, and it's students are reporting on their music popularity, but it's like percentage of what? Is that out of 100? Like, how did they structure this? We could also talk about how to structure questions and surveying methods too, but we could rerun this survey in our class and then make a better representation based on the data we collect from our students. Here's one. The gun deaths in Florida, the upside down axes. I think a lot of people have seen this one. I know Don shared this at Ohio Matic. And then another one that, how many people did they survey? This would be another good example of where we could rerun this survey in class and then come up with a better way of presenting the information. And then that would be, you know, the idea here is, okay, so we expose them to some data collection, we've exposed them to some sampling methods, we've had the conversation about appropriate graphs, things like that. Okay, the next little bit is just going to be mainly ethics. So I think number 5 is data science ethics, and then 5.2 is unfair discrimination and social biases. And that runs right into the next thing I'm going to talk about too. So I might be a little redundant here, but the main idea is we want to discern bias from fairness in like finance, medicine, like law enforcement, things like that. The big problem is data is collected by humans, and humans have biases. Humans also make choices when they identify variables and proxies, and sometimes historical biases are reinforced or even amplified. So the idea is we've got the student for a semester. We want them to be aware that just because an algorithm spits something out doesn't mean that it's not, or doesn't mean that it's not fallible. There was a human being collecting the data. There was a human being writing the code, and there might be some problems with biases. And so sample activities would be like identifying data that reflects the unwarranted biases. We can find illustrations where that affects people, like medical insurance, loans, policing, allocation of public resources, things like that. We could talk specifically about redlining. Credit scores is another one. So again, more of a conversation starter. I don't think we're going to have our one semester students going back and rewriting the algorithms, but we just want them to be aware, and we want to get them talking about that. And my next one I pulled out is 5.4, which is sampling bias. And again, that just, these are definitely linked. And we want them to be able to identify and cite various forms of biases. And again, the problems are that existing data sets contain historical biases. Algorithms can be self-reinforcing, and they affect decisions about certain things. And it can be quite a big deal depending on the situation. So again, it's more of an awareness type thing or conversation starters. So we talk about what cherry picking is. We can bring in the idea of non-response and stuff like that. And so we can get them talking about it and just kind of, what do you want to have them? We don't want them to be cynical, but it's okay if they leave with a healthy skepticism. And if we can strengthen their critical thinking skills, then that's a success. Here's a couple things that I found, just some headlines that I pulled. And so MIT, predictive policing algorithms are racist, they need to be dismantled. So that's like pre-crime kind of stuff. California was one of the first states to eliminate cash bail, and they sort of replaced it with a risk algorithm, and it just basically reinforced the existing biases, unfortunately. Hopefully those are getting a little better, but I'm not sure. And then Kathy O'Neill's book, Weapons of Math Destruction. I'm actually thinking about assigning that in my class, or at least portions of that book in my class, because she talks about how big data can actually make things worse. So we want to, expose them to stuff like that. I pulled out a couple quotes from the book, so I'll just put those on the screen, and they fit right in to where at least my mind's going. And so big data processes codify the past. They don't invent the future. And then here's a longer one. And it goes back to what I was saying about we have human beings that are doing this, and they are fallible. And this is where some of these algorithms are not available for scrutiny often, and they often reinforce things. Okay, and then I wanted to just conclude, because again, we're thinking about the person off the street that is coming in for 15 weeks, and we want to expose them to data science and enhance their critical thinking skills, and maybe lead with a healthy skepticism about certain things. So does anybody know what that app is? Does anybody like that direction app or ever use those? That's Waze, right? So certain people have certain apps that they like to use, and you'll go on a road trip and they will curse the Waze app for taking you down a country road, and I am never going to use Waze again. Then next week they do, and I'm sure we all do this. So going back to the healthy dose of skepticism, well, maybe we shouldn't rely on a direction app. Is there other ways that we can figure out where we want to go? Maybe it is nice to avoid the construction, but I don't really want to go down gravel roads in the middle of the night. That doesn't sound like a fun time. So if we use our critical thinking skills, maybe we can create a better way to get to where we need to go and not always get tricked by Waze. I know that's kind of a light example, but you know, that's the idea. So we're in the process of developing our class right now, and we're hoping to have it up and going soon, but we're having some few snags here and there, but at least we've got a lot of the stuff started. And what we're trying to tailor it to that student that we get to interact with one time, and then that's going to be it. So we're hoping that we can get that going in the next couple semesters, I hope. All right, that's it. Did y'all have any questions? I'll have to check out. I'm going to save that book from Sari.
What majors are you targeting, John? That's a question from the chat from Richard.
So we let the programs decide their math requirement. But we're trying to have enough content that if CS wanted to use it as one of their introductory things, it would be sufficient. But we could be getting communication, social work, health sciences, things like that. Once we get the class developed, we'll offer a small pilot of a section or two, and we'll see if we can't get some interest in it, and then consult with the program directors from there. We're thinking it's going to be similar to the people who would take quantitative reasoning or a 4 or 5 credit hour statistics course. So the non-STEM.
Are there areas that have reached out to you about the course?
We have communicated with our computer science people at this point, and that's about it. We're kind of going through the whole trying to steer people away from college algebra has been our main focus right now. So we haven't really gotten into this yet. But yeah, we've communicated with computer science.
There is also the comment in the chat that if a student is a CS major, wouldn't they need a more traditional math class? Is this an additional course, or is this in place of something they've already taken, or is that discussion not?
We have a CS major, and it is, I don't know if we're talked about swapping it out, but we have a couple discrete math classes that they always take. So they have like discrete math 1 and 2. It's not the exact title, but that's the idea. And we might replace one with this one.
Thank you. Any other discussion at the moment?
Did Don have a question?
Nothing from me, no.
We will have additional opportunity for questions and conversation. But next up, we have Sari Hedges from the University of Cincinnati. Sari, I'm going to turn it over to you.
Thank you. If I can get organized. Okay, so I'm going to explain the process involved in developing a 1000 level Introduction to Statistics course, or Introduction to Data Science course at the University of Cincinnati. It's very similar. A lot of the things are very similar to what John has said. So I'm going to go through the process with you, the fit within the university, the resources I use to develop it, the course itself, which we're hoping to offer next semester for the first time. I'm still working on it, so this process isn't done. So the University of Cincinnati is a large Research One university with 2 branch campuses. And this course is within the College of Arts and Sciences, within the Mathematical Sciences Department, within the Division of Statistics. There are other data science courses offered at UC. Even within the Division of Statistics, there's a 3000 level 1, a higher level 1, and there's some certificates offered in the College of Engineering and Applied Science and the College of Business. But this is fitting a different audience. Our audience, like with John, what he said, it's an additional or an alternative quantitative reasoning pathway, alternative to STEM, students who need to take calculus, or students in social sciences like psychology who would be taking statistics. This is more for humanities majors, maybe journalism or communications. These are the kind of students we see taking this 1000 level, or in other places a 100 level course. So here are the learning outcomes, and I was also on the team with John and Don to develop these. The ones with asterisks are required for the course to be transferable within Ohio, and then there's some optional ones as well. I think here's the document here, and John was talking about some of them. So I use this as the main resource in designing the course, fitting these learning outcomes. And then as another resource, some scholarly journal articles. Baumer and Horton had an article, Data Science Transfer Pathways from Associates to Bachelor's Programs. And it says that at a high level, an introductory data science course should prepare students to demonstrate the ability to, and then these bullet points. And these, the learning outcomes cover all of these, except for maybe this first one. We don't state that there needs to be a particular computational environment, but they recommend a general purpose such as Python or R. So I took that under consideration when developing the course. And then the Dana Center had some recommendations, some course framework principles in designing an introductory data science course with active learning, growth mindset, problem solving, authenticity, context and interdisciplinary connections, communication technology, and assessment. I can show you what that looks like. Sorry for the scrolling. So for example, there they have a principle, what the students will do, what the teachers would do. So I took that into consideration as well, developing this course. And then finally, not reinventing the wheel, I used existing materials and applications. And I want to thank Don Davis for providing these to me. And so I reviewed textbooks that are out there. They are all online and free, and applications that are also freely available. And the ones that are in bold are the ones that I chose to use. And I felt free to choose more than one because they are free. And also because, okay, I saw something in the chat there. Because not one book covers it all. Not one book has all of the learning outcomes covered. Modern Data Science with R was the most comprehensive, but it might be a higher level than what our students can handle at this 1000 level, but it was the only one that had anything about ethics in it. I really liked Modern Dive, and that I think Don recommended that one. That has some great step-by-step examples, but then I love the definitions that were in Data Computing 2E, so I'm going to use all of them to some extent. And then I'm going to try to use R and RStudio. But then you can see down here, I've also put Blue Sky Statistics, which is a menu-driven application that runs on R. And I'm going to try to do R in RStudio and see how it goes with this cohort. A journal article said that I've got in the PowerPoint there that less than half of high schools in the US teach programming. So I'm not sure how well this will go. We haven't offered it yet, but I will start out trying R in RStudio and maybe use Blue Sky. We'll see. Still a work in progress. And then the course itself, here's the description that was approved. It's going through the channels, still waiting for the highest level at UC to be approved to offer for spring. This is not preparing future data scientists, just like John. This is a course that will probably just have students for one semester and introducing them to these ideas and trying to get them to think critically. And I'm not going to have any exams. It's going to be project-based, and it will culminate in a student portfolio. And there again are the textbooks and the required materials. So I created a tentative weekly schedule that took into account the learning outcomes and the data center principles, and doing projects and presentations, a quiz here and there. And I've already changed it from here, but this is where I started from in creating the course. And I'm starting with ethics, which is not my comfort zone. So I appreciate John's examples there, but I have found some resources there as well, starting with ethics and getting them introduced to R, and then moving through the required learning outcomes that make it eligible for transfer. And I'm working on the Canvas course. I can show you where I am. Right now I'm working on ethical use of data, getting resources there. I'm kind of excited about this one-pager assignment that I'm going to have students do. It's like humanizing data science. It's a creative response to your learning experience. It allows you to respond imaginatively while being brief and concise and making connections between words and images. We think about what we see and read differently when we are asked to do something with what we have seen or read. We learn best when we create our own ideas. So this was adapted from another resource. None of these ideas are my own. And so I also, there was a spotlight on scientists website. And so for the data visualization one-pager assignment, they will need to choose one of the following scientists. And I had to find these. I did go to Spotlight on the Scientist Spotlight Initiative, and I could not find all of the people that fit our learning outcomes. So I kind of created my own inspired by them. So for they need to choose one of the following scientists and then do a one-pager. And they'll do this for data visualization. They'll do this for statistical modeling and data science applications. So these and some presentations. This will be ethics, lies, damn lies, and statistics. That'll be misleading graphs that John was talking about. So it's still a work in progress, but this is where I am at this point. And I hope it goes well. And are there any questions?
Feel free to populate questions in the chat if you would like. There is the comment in there. John commented that at Columbus State, they're leaning toward R at the moment. And Sarah, you talked about R and R Studio, but provided some other options. I'm kind of curious, are others considering R, or are they leaning towards Python? We do not have a course currently on our campus, so. Question does come in the chat that says, how many credit hours are your classes?
This will be 3 credit hour class.
And the comment in the chat says, to include R or Python, they need a class to be at least 5 hours.
Yeah, in the learning outcomes, it is suggested that it be 4 to 5 credit hours. But I don't think we will get it populated if we would have it at that many credit hours due to the restrictions of people's majors.
So there is a couple of additional comments that said, one issue with this course is the number of hours compared to a QR or an introductory statistics course. And I think, Sarah, you mentioned that the recommended number of hours there. Taking a look at writing textbooks or finding existing materials, going with 5 hours overall. And some additional information that's in there. Kelly has shared a great video regarding women in data science. I think to respond to an post that was earlier in the chat. And Don is appreciating some of the things that are happening as we're talking about some of the things that he will demo with some code that's coming up in there. So. Other discussion at the moment. This is being recorded, and we will post to the Ohio Mathematics Initiative website shortly afterwards. So yes, so if you didn't see the very beginning, or some of us may need to jump off before the end, it will be recorded so you can watch again. Well, I know that Don has some examples to share with us and a variety of other pieces to share. So Don, why don't we turn it over to you, and you can talk with us about some examples and sample exercises for introductory data science.
Great, thanks, Shell. I think what I want to do is to do a lot of maybe what people in your colleagues in your department might want to know is, where's the mathematics in this? Initially, when we first started this project, TMM 026 was called Data Science Mathematics. And so what I want to do is talk about 4 different examples that you can share with your colleagues that really kind of get across the math that kind of tie together the math that they know with what we're trying to do here in data science. The first thing I'll talk about is cleaning data, and I'll talk about z-scores and feature scaling. And then I'll kind of get into what I think is really the heart of this course, statistical modeling. I'll talk about k-nearest neighbors for a minute, and then talk about loss functions and decision. And we'll talk about that in the context of what are called classification models. And I'll finish up with an example of model diagnostics. So once we make a statistical model, how effective is it? That's what we want to look at there. And I think in terms of teaching methodology, we want to do what you, let's say you teach a class, a statistics class, and you teach a topic like bootstrap resampling. What you might want to do is to show one step in bootstrap resampling, and then maybe show 5 or 10 steps culminated, and then you can just take off and do like 1,000 steps. So what I want to do is something similar to that, is to kind of show the step part, and that's what I'm going to do here today. One step in cleaning data in the data science cycle is to clean out outliers, extreme or in many cases erroneous data. And certainly one way to do that is to calculate z-scores. And we work with sample data in data science. So think of all these as being sample statistics. And we can identify extreme values numerically by using z-scores, or we can do it graphically by doing things like box plots. And in terms of data curation, the first of the 4 areas of introductory data science, we want to be able to rank the data we have, and we can use that. We can do that using what's called simple feature scaling. So let's scale data. Let's scale data, and we'll define it as X subscale. So here's feature scaling, where we take a particular data item, divide that by the maximum value, and we often want to make that a percentage, so we'll multiply it by 100. So the range of values for simple feature scaling is 0 to 100. Now let me show you an example of this. Now I know it's hard to look at one of these spreadsheets. If you look at the 3rd column there, what I've done is taken the Gini index for the administrations from Presidents Nixon up through 2018, and I've done simple feature scaling with the Gini index. So if you've taught a class like business calculus or applied calculus, I think you might be used to the Gini index. It's a measure of income inequality. And one more thing I wanted to talk about with this data, if you look over here, 3 columns over, I also took the poverty rate for each year during each administration, and I did what's called max-min scaling, where we take each data item, subtract the minimum value, and then divide that by the range. And let me show you the graph that I came up with this. There it is. So if you look across the bottom, the horizontal axis, that's the number of years since 1974. If you look at the vertical axis, that's the Gini index on that simple feature scale. And you see the different colors for the different administrations, and the size of each dot is determined by the poverty rate for each administration. Well, for each year of each person's administration. So if you're into the Gaze guidelines, you know that multivariable thinking is what I call the 1B goal in the Gaze guidelines. Here you see a graph with 4 variables on it, on a 2-dimensional graph. So that really kind of goes into the second part of the 4 of the areas of data science, that being enhanced graphic, what we call it, enhanced graphic abilities. All right, so let me talk about some machine learning algorithms just a little bit. And I think if there's one machine learning algorithm you want to teach in a course like this, it would be this one called k-nearest neighbors. So let me briefly outline it for you and kind of show you how it works. First, we assign a value to k, the decider value. Typically, we do an odd number. We calculate the distance between any new data entry and all the other existing entries and arrange them in ascending order. And then we find the kth nearest neighbor to the new entry based on the calculated distances We're majority rules. That's why we want to have K to be an odd number. And then we assign the new data entry to the majority class in the nearest neighbors. So let me show you what I mean by that. Here's an example. We use the Euclidean distance formula to determine if the green dot in the middle belongs to the red group or the blue group. Now, notice I use the term Euclidean distance formula as opposed to the Manhattan distance formula, which is the sum of the vertical and horizontal displacement, which is a good way to calculate distance if you have discrete or ordinal level data. All right, I went ahead and calculated these distances so you don't have to. Now, notice here, we have these distances. I rounded them to 2 decimal places here. Here it would not be to our advantage to write the distances in irrational form. It would be very difficult to compare the distances. So you can see here, if you just look at the distances on the right side compared to the left side, that the green dot would belong to the blue group. So that's really essentially what K nearest neighbors is about in terms of classification. Now, sticking with that notion of classification in machine learning, I'll talk for a minute about calculation of loss functions. So the aim here of classification modeling is to foretell categorical values using a statistical model, all right, where the target variable is categorical in nature. So loss functions for classification can be seen as a price for guessing wrong. So the simplest loss function for these classification models is called absolute loss. So let's take a look at one of those. So let's define what absolute loss is. We can, if we let y represent an observed value and let p represent its associated probability, then the absolute loss is the absolute difference between that observed value and its associated probability. So we can do that for the entire data set by simply adding up the loss for all the data and then dividing that by the number of observations that we have. All right, so let me do a quick example of this. Again, think of this as you're trying to convince your colleagues who maybe don't teach statistics, who don't know much about data science, how to go about, where's the math? All right, so nursing students often take this HESI exam as a precondition to get their license. And so let's consider a set of sample data where we have the number of hours they study for the HESI exam in the top row, and whether or not they pass that exam in the bottom row, where pass is coded with a 1 and failing the exam is coded with a 0. So that brings us to a logistic regression model. There's the actual model right there. Let me show you a graph of it. Now, when you see a logistics curve like this, I think one thing you want to do is to find the inflection point. That's quite often called the threshold point in data science. And to get that value, what you do is if you take a look at that linear function that's in the exponent, that's in the denominator, we simply take the opposite of the constant and divide that by the coefficient of x. I think in this case, that number ends up being about 56. So you can see that there were students who studied less than 56 hours that passed the exam up at the top. And then you see some students who studied more than 56 hours that failed the exam, and those are the dots on the bottom. And so from there, we can go ahead and start to compute absolute loss. All right, so let's determine the absolute loss for someone who studied 58 hours for the exam. So I calculated P of 58 using that logistic function you saw, and I got about, 44% or so. And so there is the absolute loss for that data point. So you can see here's the step part of the step walk and run. And to get the total loss, we just simply want to repeat this process for every observation. So I'll show you what that looks like. All right, and you can see why now you want to certainly have computers to do this stuff for you, because that's a lot of calculation. All right, so we see the total absolute loss is about 0.647. So that's just one loss function for classification. Another one is the log loss function, and it's a little more complicated. All right, and you can see there where in this case it would be kind of difficult to do this one by hand. You'd certainly want some technology to help you with it. All right. Finally, I want to talk about model diagnostics here. In supervised machine learning, that's machine learning in which we know the outcome, and we want to build a statistical model to reflect that can best measure that outcome and predict that outcome, so we can classify data. So we can measure the effectiveness by splitting the data we have into a training set and to a test set. Typically, the training set is the bulk of the data, where as we randomly choose about 75 to 80%, and the remainder is our test set. So using the test set, we model against the known observations of our target variable, the one we're trying to classify. And the results are summarized in what's kind of a weird term called a confusion matrix. It's really anything but. I'll show it to you here. If you teach statistics, in particular inferential statistics, you're used to seeing this kind of contingency table. If you look at the pink cells on the main diagonal, you see the true negative and true positive responses. Those are correctly classified. And if you look in the off diagonal, you see the false positives and false negatives. And those represent mistakes we make when we do our statistical modeling. So let me show you an example of this. We can go ahead with a confusion matrix and define some key values. The first one is called accuracy, and that gives us an overall sense of the model's performance. So notice what it is. It's the sum of the true positives and true negatives divided by the total number of observations we have. And then the other one I'm going to talk about is precision. So notice here, that value measures how precise our positive predictions are. So we take the true positives and divide it by the sum of the positive responses, and that gives us our precision. So let's look at an example for this. The confusion matrix for a target variable, and this is data is some data I got from Kaggle, I believe. It was on determining whether or not someone gets a bank loan. And we have the data for 614 observations. So let's calculate the accuracy and precision based on the results and interpret each one. So here we go. So the accuracy, notice here, the total, the true positives and the true negatives over the sum of the observations is calculated. So that means about 80% of the true values were accurately predicted. And then the precision, remember that was the true positives over the sum of the positive responses. Ended up being 79%. So this means about 79% of the positive predictions were precise. And let me just finish up by making a little note here. In terms of model diagnosis, there are other measures I didn't talk about. Those include sensitivity, specificity, and the F1 score, which is the harmonic mean of the accuracy and the precision. So Shell, that's it. That's what I have in terms of sharing some examples.
Thanks, Don. Folks, do you have any comments or discussion over the examples that Don's presented? There was some appreciation for your jury matrix of type 1 and 2 errors, Don, if you haven't seen the chat. So I do think that seeing the examples and talking through some of the things that are presented is very much helpful as we're thinking about creating courses and what what has been done before. So, any other discussion at this moment? We have Martin with us, who's also going to share a little bit about his processes in creating a introductory data science course. So I'm going to turn it over to Martin, and he can share with us his insights.
Well, I'll give you a first insight is that I'm connected on 2 devices and the video is not synced. So at the previous speakers, sometimes I saw what they were talking about and sometimes I saw what they were talking about a minute ago. So if you have that, I'll try to not switch screens very much so that doesn't happen for me. Okay, so I'm going to talk about a course I developed here at Ohio University, and I taught it last year, fall and spring, and it got approved in the TMM. And let me put a couple of links in the chat in case you want to follow along or for reference later. It should have worked. Okay. So I'm just going to kind of talk you through my process, and I can demo a little material if there's interest, or if I just guess there's interest. So first, I should hide that. My objectives. So a primary objective was to satisfy this TMM, partly because in our general education system here, to be approved for general education, it has to be TMM approved. So this was not an optional thing for me. A second objective was to use existing open resources. Some of that is just my own principle of using open stuff, and some of it is I don't want to create content if I can help it. There's a lot of good stuff already out there. Although sometimes it's fun to create content, that is not a goal. I'd rather reuse stuff. And then a third objective is to follow what the experts have done. This is not a new kind of course. Other people, other places have done it. And every time I had an urge to reorganize or rethink their choices, I had to squash that urge and say, no, you know, they've done this for 10 years. Let's do it their way. So, and a specific course I liked is UC Berkeley's Data 8. They've been doing it 10 plus years. It has exploded. They teach like 1,200 students per term in this course. Very popular, and because it's such a big course, they've put in time and effort to develop resources. They also have an outreach component, so they shared their materials with me, you know, and that is an awesome thing. So those were my objectives, had for a while. And then to get from there to something, here was my thought process. So first, what resource to use? No single textbook satisfied all the stuff in the TMM. There's a nice grid showing that they probably Don supplied with a bunch of books and which ones they covered, but nobody covered everything. So I would need to collect and organize stuff from other books. And if we're going to reuse this rather than do it on the syllabus, I thought I should make my own kind of textbook. And then I fretted about this for a while, how to organize it. And then a real kind of epiphany was to organize it with sections exactly like the TMM. So it would definitely fit. It would force me to make it fit and cover the right stuff. And maybe I'll show the book near the end here. A second decision was what language to use. So I did like Data 8, but I wasn't wed to that yet. It uses Python. I use Python myself. Our computer science department teaches a Python course. Hardly anybody here use R. Some of our stats people do at the senior level, but nobody outside of math was going to give any support for R, and other people will use Python. So that fixed Python in my mind. I've used both in the past. My general thought is R is fine for statistics, but Python is general use. And I would also like these people to be able to use Python for other things. A kind of sub point of that is we don't want to teach too much Python. It is not a programming class. The Data 8 has a special Python library that they developed for teaching data science that has some abilities, but also intentionally does not have other abilities to keep you on focus. So for example, it teaches the for loop because you need to iterate, but does not teach a while loop because you don't really need it. So being very intentional about which things to include and which ones not to include. Another thing, again, inspired by the Data 8 people, is you want to minimize student software access problems. And so what they did, and again, I'm following them, is to use a Jupyter Hub. And let's see how long this will take to launch. So here I clicked on a link which would be on my syllabus. Then I click on which course and hit start. And what it's doing is it's pulling materials off of a GitHub repository that I set up. And then we wait, hopefully not very long. And it pops you right into the homework. And this is a Jupyter notebook. So it's got executable cells. And let's see. I didn't have any good demos in there, but this is code. These are code cells that they would fill stuff in on, and they're right in the homework. So since it's through a web browser, you can access it from anywhere with a decent internet connection. A fourth point, which I see now I've deviated from everybody else, is that here we can't afford to have a terminal course of this type because we can't have more courses. We have too many courses, not enough resources. It has to serve multiple purposes. So the goal is to make a class that would be general education, could be taken by people in many majors, but would also be the starting point for someone who wanted to do a math major with data science stuff, or if we make a data science major or minor or statistics certificate, it would start with this course. And that is also the way that Berkeley does it. Where do you position it? And again, I think everybody else is thinking this is placement level of college ready. The Data 8 course has prerequisite of got into Berkeley, which I thought would be higher than college algebra, and realistically it is. So I put it at placement, the same placement level of pre-calculus as kind of a compromise. So it's not, our placement level is, for quantitative reasoning, is lower than that. So this is one step up. So far last year, I had 5 students in the fall and 7 in the spring, and they were all like junior, senior math majors. So those were the ones that recognized the value and took it. Last year, it wouldn't count towards general education because it hadn't been approved yet. So moving forward, I hope to get more people.
Martin, there is a question in the chat. What level is the course and what's the course number here?
It's 2530. So, again, it's 2000 level, but its placement as far as incoming students is the same as our pre-calculus, which is a 1000 level. So you can take, if they place in lower, you can take either college algebra or the introductory statistics and use those as prerequisites for this course.
Do you think it will mostly be the math majors who take the course?
I hope not. It's designed to be more general. I think people who are non-STEM don't really want to do math so much are better off taking a quantitative reasoning course than this one. But people who are, say, a sociology major, but have some interest in using data for sociology, I would like them to be able to take it. Yeah, and that's something trying to figure out a little bit to advertise it, to get students into it who would want to do this, who are not STEM necessarily, but do have some quantitative interest. Okay. Also in process, I wanted it to be scalable and sustainable. So, in my dreams, it gets 1,200 students like Berkeley. It'll never get there, but I do want it to be able to scale to a larger number than the 7 I've had, and also sustainable. Archive all the materials and make it so it can be really used for a long time by many instructors. So part of that is all the materials and stuff are done through GitHub, and it uses an auto grader that the people at Berkeley developed. So you get their Jupyter notebooks and run the auto grader on it to get sort of partially graded assignments. The auto grader also gives the ability that the students, as they're working, can do checks on their own work. So they run a test that's kind of public, it's in it, and says, no, your array is the wrong size. And then they know to fix that before they submit the part that you test. And your test might be, does it actually have the right numbers in it? Okay, so that's scalability and sustainability. Okay, so some outcomes and things that might be useful for other people. So there's a textbook, which I put the link in the chat. And it is exactly organized by the TMM. So chapters and sections. It even quotes the learning outcomes and sample tasks from the TMM, because again, I'm lazy, I don't want to reproduce stuff. And then typically it says, okay, go read this particular other material from another book. And I put in reading questions just so we have something to discuss in class. So, click on that, then you get into one of these other books. This is on the web. Anybody's welcome to use it, and it is organized like the TMM. And I didn't fill in the optional topics, but everything else is filled in. Second thing, if you just want to get ideas for materials or see what's in this course, because it's managed through GitHub, you can go to, this is the public repository that students are drawing stuff from. They don't really need to see this interface, but you can go in, pick a homework assignment, and you can open these right in GitHub for view only, but you can still see what's in it, see the materials. And you'll notice there's a lot of things like, this is based on Data 8, Spring 20 Homework 6. So again, a lot of it came from them. I had to reorganize and update a little bit. But this can give inspiration if nothing else. There's a syllabus, which is maybe less interesting, but shows how I organize things. So policies and stuff, and then a calendar. So this is sections in the text and homework, so you can see how my weeks went. And these, if you directly click on them, it won't work because it's going to the Ohio University Jupyter Hub. but it's the exact same material that's in that GitHub repository we just looked at. Okay, I guess I should have commented some on that. So the materials, about 80% of it is from Data 8, just reordered. About 10% is from Berkeley's second course, which they call Data 100. That's stuff that was not in the Data 8, like data cleaning was not in Data 8, so I had to modify that a bit more. And then about 10% I had to make new stuff. Syllabus, this is a 4-credit class. It's organized as a Monday, Wednesday, Friday lecture, and then an 80-minute Tuesday lab. That was, again, inspired by Data 8, which has labs, and then if this ever gets large, you could have larger lectures and smaller lab sessions. I structured it to have weekly homework like the Data 8 course and have it labs like the Data 8 course. As far as the materials go, homeworks are designed to be once a week. You need time on your own to work on them. The labs are designed to be started and finished in one session. And mostly all the tests, auto-graded tests, are public in the lab. So if they did it by the end, then they know they got it right. It's sort of more of a doing it credit rather than did you did. Yeah, okay. If you did it and got to the end, you get credit for it. The Data 8 course has 3 projects, or sort of canned projects. So they're long things, but all preset questions. I didn't want to have another type of activity in this course, especially the first time I taught it. So I broke those up and made them like 2 homeworks for one project. I do have tests, and I don't really like the way the tests work. I'm thinking doing some projects, like individualized, open-ended projects might be better. But last year I did tests. The delivery, this is not so much, this is just the way I do my courses when I can. I don't like lecturing, so I didn't lecture much at all, except for something they got really stuck on. We would have some discussion on the readings, but again, that's pretty brief, maybe 5%. And most of the time, they are working on the homework in the labs, lab assignments. And we're holding it in a computer lab classroom. So they have computers right there. They can sit next to each other, help each other, get my help. And it's really a hands-on, active class.
There is a question in the chat. Someone's curious as to whether SQL is taught as part of this data science course, a SQL.
I did not. Like in the Berkeley ones, it's in their second course. So there you have to make the conscious decision of what's going to be in the first course and what's going to be in the second course. And I followed them.
Thanks.
So some observations. So the Data, they have a technology stack, and it's kind of daunting. Of course, it depends on what you already know. So the materials are all done through GitHub, so you need to know how to do GitHub. I did what I think actually the Data 100 did this. I used the GitHub Pages thing for the syllabus, so that's all stored in GitHub, and then it's served through the GitHub Pages. The textbook, I used the Jupyter book thing, so you're again writing Markdown and a few Jupyter notebooks and compiling it. You need to use Docker for the autograder, so that's making virtual machine images for the Jupyter Hub and for the autograder. The autograder, which is called autograder, is kind of finicky and takes a bit of effort to get that to work. And a couple times it stopped working suddenly, and then I had to figure that out. It's run on a Jupyter Hub, which took a lot of poking and whining to get the university to run that. It's not actually hard to run, and it's all open source. It's free, but they still complain. But somebody has to run it, And so, you know, this is all doable. People have done it, but it was a great deal of effort and stretch for me. I spent much of summer 22 getting this all to work. And I've been using Python 20 plus years, and I'm a Linux user, and it was still a stretch. And as a Linux user, you know, all these tools are like, use pip install to get the tool, and that's fine under Linux. I don't even know how that works under Windows. I suppose it can work, but I don't even know. It's an ecosystem designed for Linux users. And so that final observation is, you're not going to take a random math faculty and say, hey, you got 2 months to do this. It's just not going to go. Okay, the question, we don't have separate statistics faculty. We have basically 2 people in the math department who would be considered statistics. So because few math faculty can do this, and I'm also chair and need to do other things too, we use this as justification to hire a new assistant professor, Will Clark, who he was here. I assume he's still participating. All right, that's my presentation. Any questions?
Again, feel free to post any comments or any questions in the chat, and we'll get those relayed. I will say that your comment, few math faculty can do this. Some of this does sound a little daunting. I'm a reformed computer programmer who has been away from programming for quite some time, and I'm just thinking about all of the new pieces to put together. And so I guess in there, what would you suggest to somebody who might want to learn or doesn't have a lot of background to start with? Where do we start?
I think my first advice is, you can't think of this as, I'm going to learn this in a month. It has to be a long-term process of developing your own skills. For the particular data science part, read the Data Aid book. I think they even have a Coursera version of the course. Take it yourself, do it yourself to get going there. Some of it is, though, the mindset of, oh, I want to learn to program, I want to do it for stuff. I started just sort of for fun doing data science-y things for my own classes, like analyzing student grades and scheduling, using the tools to develop proficiency. It wasn't so much a how to start as just how to get the right mindset. That you can't think of, I'm going to learn this in a month. You got to think of, this is a process of developing experience over a year or 2 or more.
Thank you. Comment about justifying new faculty could be difficult if students aren't enrolling in the class.
Yeah, there's a little bit of a cart before the horse. They won't enroll until you have the course. Some of it is, we had a university trustee who was saying, hey, why don't you all have any data science? And they put this, I shouldn't say that in a recording. They pressured the provost to get some data science going. So then there was a whole effort. They want a major and a minor and a certificate. And I can realistically say, well, we can't even offer one course unless we have people with expertise.
Is there other discussion right now based off of Martin's presentation?
I had something in the chat earlier just thanking him for the information about the textbook, because yes, I need to incorporate multiple textbooks, and that was useful to see how you did that.
I do think that we appreciate all the different materials that we've seen here and some understanding from all of you on how you've put things together, or you're starting to think about collecting examples or collecting resources to put together a course. I do know that Don has some additional examples, some additional discussion for us. So Don, can we turn it back to you?
Sure thing. Let me make a few comments first. If you are within the sound of my voice, go look at Martin's book, because I talked about supervised learning earlier. It's a natural question. Well, what's unsupervised learning? You can go there, get a link, and define it. What's k-means clustering in supervised learning? You can go there, find a link, and it'll take you to one of these books and explain that to you. And so, and as he emphasized, his book links to material that's directly associated with the learning outcomes of TMM 026. Second, in terms of commercial textbooks, I contacted every commercial publisher and asked them if they have a introductory data science textbook. Every single one had the same response. No, and would you like to write one for us? So really the only commercial textbook available right now is what Sari talked about earlier, which is Data Science Foundations, Zybooks. They have the Python compiler built into their textbook, so it's very convenient and easy to use if you want to go the Python route. Now, what I want to talk about is more of a workflow solution. So let me get that up for you here. This is a program called Orange, and it's let's see here. It came from Scandinavia somewhere. It's open source, free to use, free to download, and it's what's called a workflow application. If you take a look here, you see these connections, and you see these circles. Those are called nodes. Think of those as a chunk of Python. So this is what I used for that last example I did. First, here's the number of variables. We were talking about the loan amount, and I made the target variable, if you recall, whether or not someone got a loan or not. You can, and I'll show you the raw data. There it is there. That's in the data table node. And notice there's some missing data down here. And that's where, this is what Sari kind of got me into, this idea of imputation. So let me open that up. And this accounts for missing data. About 2% of the data I have in this data set is missing. So what you can do is to, you can use this imputation method where you can delete the data that's the occurrences associated with missing data. You can substitute it with an average or the mode, depending on the nature of the data. Or you can assign a random value from the data that exists in a bootstrapping fashion. So I'll go ahead and use that last one there, and I'll apply that. Now, if you watch the workflow, you'll see it recalculate everything, and that's where those little circles come into play. And I also did, the data visualization with some bar plots and some scatter plots. I started looking at the data, and I kind of thought maybe application income and the loan amount might be some two good variables to target whether or not someone gets a loan. So notice here, I have these three statistical models. Those are the pink nodes there in the middle. K nearest neighbors, naive Bayes. That's simply Bayes' theorem without the presumption of the events being independent and collectively exhaustive. And finally, logistic regression. That's one of them I talked about earlier. And you can test the values, and that will give you the accuracy values and the F1 score. Here's the confusion matrix based on the observations we had there. And we have different results for each of these machine learning algorithms. And then finally, there's this receiver curve, which kind of gives us an idea. And if you kind of look at it, it kind of reminds you of the Gini index in a way. It gives an idea of model performance for these three statistical models. And the ones that curve out here the most are the ones that are most accurate. The identity line here represents total randomization. All right, so again, this is free. It's called Orange Data Mining. There's another application just like it called KNIME, spelled Knime, and that's in addition to the other menu-driven programs that Sari talked about. Those being JASP, which is has a very nice machine learning module in it, and also Blue Sky Statistics, which is a menu-driven R application. So I just wanted to show you some things that you can, if you don't want to scare your faculty and they don't want to have to learn R or Python, that's a good way to go. All right, I'll give it back to you, Shel.
Thanks, Don. I appreciate it. We have heard some, I think, really interesting things today, and we've seen, I think, a lot of useful information, talked about several different types of applications. I think we're probably all kind of sorting through a bunch of information in our heads, but additional commentary, or now that we've heard from each of our presenters, questions that you may have from them. And I think we're probably a small enough group that you could unmute yourself and ask your question. I think my request would be is that if you want to direct it to a specific presenter, that you let us know who you'd like to target your question to, or if you just want to open it up to everyone. We'll also continue to monitor the chat. Don, I'm going to ask you this question, Don. You were talking about orange, and what was the last one? Was it KNIME?
KNIME, yeah, Knime.
Okay, KNIME. Are there, I don't know, are there places to go to see it in use or to explore? Or for those of us who have no idea at all, what's a good place to kind of even start just seeing what these things are?
Yeah, Orange Data Mining has a series of videos which demonstrate each of the nodes and how they work and how you connect one node to another and what the purpose of it is. KNIME has an actual class you can take,
Okay.
Kind of a MOOC, and where you work at your own pace, and you can you can do data cleaning, and you can do all the other processes in data science. JASP does not have a data science book, but they do have an introductory statistics book. So that might be a good bridge so you can start to learn how to use JASP, just another statistics program. And kind of get a connection between introductory statistics and introductory data science. And I will say that Blue Sky Statistics just came out with a new version, which makes it much easier to use, I think. So those are all free and open source for download.
Terrific. And if folks aren't following along in the chat, Sari has put in a couple of links or a couple of references, and Daisy has made the comment that R has swirl packages that we can learn at your own pace, different aspects of R, and that's how she went through and learned R. So thank you. And then there's the link for Blue Sky Statistics as well. Other comments, other observations, folks? Now that we have,
Oh, sorry.
go ahead.
This is Eric. I'm just opening up to people who have offered it or who are have it well mapped out, but I'm wondering about the ethics and the law and legal part of it. There's so many laws and regulations, and how extensive are people covering that? What are they planning for that part? Like it says, oh, sorry, consider the local legislation and identify relevant laws, rules, and regulations pertaining to the protection of personal data.
I had the same question. That's my area that felt asked me to work on was section 5. So
There's
So-
federal law, there's state law, there's local law, there's European law. Sorry.
So some of the sample tasks mention the European law and the U.S. communication decency and California's law. So those you can find on the web. And then I gave an assignment for them to figure out whether the data protection's under Ohio law, which if you look hard enough, there's none. But it's a good exercise.
that's a good idea. Send them on a wild goose chase.
Well, there's a bill, but it's been stuck for a couple of years. So they find the bill and they say, "Oh, we've got these protections," and then you can point out that it didn't pass.
Thanks.
But I will say that the data ethics chapter was the hardest to find stuff for, and to find interesting exercises or.
The trouble I've been running into is I can find books, but I don't want to necessarily assign an entire book. And then finding excerpts or articles or things like that have been tricky too, because I want it to be something they're actually going to read. And I feel like if I assign a 300-page book, then I don't know how many people are actually going to go for it.
I found a website called integratedethicslabs.org that had some good stuff. I'll put it in the chat.
Super.
Don has also shared that Modern Data Science with R has a good ethics chapter as part of it. And Sari has put the link to integrated ethics labs into the chat.
Yeah, Modern Data Science with R was the only one that had anything about ethics.
Other questions or other observations? John or Sari or Don or Martin, any last thoughts you want to leave the group with?
Wish me luck, and I hope that I can use all of you as resources to collaborate with.
And I think that's what we're thinking about all of you, is that we hope we can use you all as resources.
Yeah, that was the entire idea, I mean, of this webinar, is to create a network so people can ask questions and get resources.
Yeah, build capacity. It's a long-term project.
So probably we will do this again at some point in the future, because the number of institutions that are going to start offering this data science, introductory data science is going to increase. And I'm extremely glad that we have the group of experts, because I think that this webinar was very, very illustrative and very good.
So we do have a thank you to folks for presenting today's webinar with a comment that it was needed, and I would agree that I think a lot of folks are really just trying to get up to speed, kind of like the title implies, and figure out what's out there and what's workable and what are folks already doing or trying. And I agree, Ricardo, that I think we'll see need for more of these. I think as folks get a little bit further along in the process, our questions are going to change and become more refined, and we'll go from there. And we know who our experts are. We've got some thumbs up that I can see. Anything else as we prepare to wrap up today then? Well, I'd like to extend my gratitude to John and to Sari and Don and Martin for agreeing to present and share with all of us the things that you are trying. There are clapping hands coming up the side if you haven't seen them, because I do think that that is very, very helpful. Ricardo, much appreciation for helping organize these things and putting forward some of the building blocks we need as we start to develop these courses. And to the folks at the Ohio Department of Higher Education, Michelle Blaney in particular, who spent time trying to put some things together and wrangle a bunch of different ideas so that we had a cohesive presentation, a cohesive set of ideas to share with all of you today. I'll remind everybody again that this was recorded. So take a little bit of time to render and then to get posted to the Ohio Mathematics Initiative website.
We lost you. We lost your sound.
Back?
Yes.
Okay. So we'll get the recording posted to the Ohio Mathematics Initiative website. We'll get that back in the chat in just a minute. It usually takes just a little while to get posted, but so that you can view again or you can share with colleagues who were unable to attend today. But again, thanks so very much for your participation. Please feel free to reach out as you have questions, either to the Mathematics Initiative. Our presenters shared with you some of their information as well, and we can get you connected. There is also a presentation form on the Ohio Mathematics Initiative website where you could request presentation, or you can request future webinars or information. And so if you have ideas or you have specific needs, please let us know and we can work to get those things organized. But again, thanks everyone. Appreciate your time and your attention today, and have a wonderful afternoon.
Thank you.